Welcome to this video on ethical design practices, focusing on building responsible AI from the ground up. This week, we will cover 5 key areas: why ethical design is crucial, the 6 stages of the ethics-first AI project cycle, 7 core ethical design principles, practical approaches to implementation, and current regulations and best practices. As we begin, consider these fundamental questions. How do we ensure AI systems benefit society without causing harm? And can we build AI that is both powerful and ethical? Ethical design matters because AI has real-world impact, affecting millions daily. Trust is essential for adoption, as 86% of people are concerned about AI ethics. Further, new legal requirements and the risk of billions in fines make ethical practices mandatory. Ethical AI development relies on 2 pillars: process, which is the ethics-first AI project cycle, and principles, specifically the 7 core design principles, including fairness, transparency, and accountability. An ethics-first approach means ethical implications are considered proactively, before and during technical development, rather than as an afterthought. This helps avoid harm, builds trust, and ensures compliance from the start. Recent failures show the risks of neglecting ethics, from Google Gemini generating inaccurate images and the Air Canada chatbot giving false legal information, to ChatGPT jailbreaks and the Amazon AI hiring tool discriminating against women. Now, let's dive into the AI project cycle, focusing on how to integrate ethics at every stage of development. The ethics-first AI project cycle consists of 6 stages: problem scoping, data acquisition, data exploration, modeling, evaluation, and deployment. It's a continuous cycle, with stages revisited as needed. Stage 1, problem scoping, uses the 4 W's framework. Ask, who are the stakeholders? What problem are we solving specifically? Where will this be used? And why does this problem matter in terms of real human impact? Ethical considerations in scoping include asking if you are solving the right problem, who benefits or might be harmed, whether you are reinforcing biases, and what unintended consequences might arise from the AI solution. Stage 2, data acquisition, requires informed consent, privacy protection through minimization and anonymization, ensuring representativeness, maintaining legal compliance, securing data, and documenting transparency. Stage 3 is data exploration, focusing on finding and addressing bias. Look for imbalances in representation, check for excluded data patterns, analyze correlations, use statistical tests, and document limitations. Stage 4, modeling, requires building transparent and fair algorithms. Choose interpretable models, implement fairness constraints using tools like IBM Fairness 360, document all model decisions, and build in explainability features like LIME or SHAP. Stage 5, evaluation, involves rigorous testing. Use fairness metrics to check accuracy and false positive/negative rates across groups. Conduct security and safety testing, including adversarial testing and privacy leak detection. Stage 6 is deployment. Ethics does not stop at launch. Monitor for bias drift, implement user feedback mechanisms, establish incident response, perform regular audits, and maintain transparency logs for accountability. The Microsoft Tay chatbot disaster of 2016 illustrates this point. Within 24 hours, it posted racist content because it lacked content filtering on training data, sufficient adversarial testing, and human oversight before deployment. Next, we will review the 7 core ethical design principles that guide responsible AI development. These 7 core principles are fairness and bias mitigation, transparency and explainability, accountability, privacy and security, human-centered approach, user data rights, and reliability and robustness. Principle 1 is fairness and bias mitigation. AI systems must treat all users equitably. This requires testing for disparate impact, balancing datasets, using fairness metrics like equal opportunity, and conducting regular bias audits. Principle 2 is transparency and explainability. Users need to understand how decisions are made. This means disclosing interaction with AI, explaining the model's training data, showing why specific decisions were made, and being clear about the system's limitations. Principle 3 is accountability. Organizations and decision-makers must be responsible for AI outcomes. Key requirements include clear ownership, detailed documentation, incident response procedures, regular audits, and mechanisms for redress. Principle 4 covers privacy and security. Privacy measures include data minimization, anonymization, and retention limits. Security involves encryption, strict access controls, breach detection, and strong incident response. Principle 5 is the human-centered approach. AI should augment human capabilities, not replace judgment. Design should prioritize user well-being, offer control and cognitive support, align with human values, and include human oversight to override AI decisions. Principle 6 focuses on user data rights, giving users control. These rights include access, correction, deletion, portability, the right to opt out, and the right to an explanation of how their data affected AI decisions. Principle 7 is reliability and robustness. Systems must perform consistently, handle errors gracefully, and fail safely. This includes rigorous testing on edge cases, ensuring adversarial robustness, and continuous performance monitoring. For a hotel AI assistant, the principles mean it must be fair across all guests, transparent about being an AI, and the hotel is accountable for its behavior. Data is kept private, and guests have control over their information, with human backup available. A practical tool is AI ethics cards. These cards prompt interdisciplinary teams to ask critical questions about stakeholders, potential harms, and the underlying values guiding the AI's design. Now, consider how to balance competing ethical principles. For example, more explainability often means less accuracy, and greater privacy protection might reduce personalization. These trade-offs must be actively managed. Finally, we examine practical design approaches, moving the ethical theory into everyday practice. 3 main approaches integrate ethical design: top-down, encompassing regulations and corporate policies; bottom-up, which includes community-driven and participatory design; and rule-based, leveraging checklists, frameworks, and standards. The top-down approach includes governments creating laws like the EU AI Act, corporations forming internal ethics boards, and standards bodies like ISO developing technical guidelines. The bottom-up approach emphasizes involving affected communities from the start through co-design workshops, feedback loops, and diverse teams to ensure those impacted have a voice in how the AI is built. The rule-based approach provides practical tools like ethical checklists, AI ethics cards, fairness metrics for quantitative measurement, privacy impact assessments, model cards for documentation, and risk matrices. Global AI regulations are rapidly evolving. The EU AI Act uses a risk-based approach, while the US executive order focuses on safety and equity. Other nations like China and the UK are also establishing governance frameworks. Regulatory uncertainty is high in early 2026 due to conflicts between US federal and state laws and international adjustments in the EU. Organizations must monitor these developments closely, as compliance requirements are rapidly changing. Anthropic's responsible scaling policy illustrates a proactive safety framework. It uses AI safety levels, or ASL, where safety requirements become more stringent as model capabilities increase, potentially pausing powerful model training until safety measures are ready. Generative AI introduces special challenges, including hallucinations, copyright issues in training data, the risk of deepfakes, and prompt injection attacks. Responses include fact-checking, watermarking, and adversarial testing. The best practices include embedding ethics in every stage, using diverse teams, documenting decisions, testing comprehensively for bias and security, implementing human oversight, monitoring continuously, and prioritizing user well-being. In summary, ethics first is proactive. The AI project cycle requires ethics at all 6 stages. The 7 core principles guide design, and regulations are mandatory. Generative AI poses new hurdles, requiring comprehensive best practices for responsible development. Thank you for engaging with this video on building AI that benefits everyone. Remember, ethical AI is about actively creating systems that make the world better. For more content like this, please like and subscribe to my channel.